Okay, dobro jutro. Unfortunately, that's my level of Russian, so I'll have to do this in English. I can count to 10, so we can play hide and seek, but that's pretty much it. The topic for the next two talks is going to be moving from quality assurance to quality assistance. And the way I understand the program is I'm supposed to talk for about 40 minutes and then we take a coffee break and then I get to talk for 40 more minutes. So in the first half I will mostly talk about what benefits companies get from this model and how to get people to start changing. What are some organizational ideas to start changing? And in the second half, I will talk about some more tactical and practical ways of doing different ways of working with teams. So the first part is going to be a bit more philosophical. The second part is going to be a bit more practical. I do a lot of work with teams, helping them improve quality and improve their testing processes. And a couple of years ago, I had this request from a client to help them hire their first tester. By that point, they had about 12 developers working in the group, and they were developing some video games, and they started getting maybe 2 or 3 bugs a month that got to production. And they were starting to get worried about that and decided they need to hire a tester. And the person I interviewed there, they asked me to interview.
Меня попросили провести интервью. У них не было такого опыта. Я провел интервью с парой людей. И я нашел.
Who was probably the best tester I ever hired for anybody. Absolutely brilliant person. He knew exactly what needed to be done. He had experience in the model, in the domain. He had worked with similar companies before. They liked him, he liked them, it was fantastic. And then 6 months later, they called me and they said, we would like you to help us find another Samir. I said, brilliant, so this thing really worked out for you. And they said, well, not really, but we need another one. And I said, well, what do you mean not really? And they said, well, we're getting more and more problems now, we need more testers. I said, what do you mean you're getting more and more problems? I said, well, now we have about 15, 20 bugs going to production a month. I said, well, before you had a tester, you had 2 or 3 bugs going to production a month. Now you have 20, 30 bugs going to production a month. Are you sure you want another one? Is that a good idea? And they said, no, but he's brilliant. He's helping us test and everything. He can't, finish all the work. So there's lots of stuff going untested. And what happened there is very, very illustrative of what I've seen happening with lots of organizations. When there is a person with the name tester, then all testing becomes their responsibility over time. And before they had any testers, everybody was testing. And developers were testing, the business analyst was testing, but now they had a tester. Over time, he was trying to be really helpful. He was trying to kind of accept as much work as he could, but there's no way for a single person to test the work of 10 really good developers. Or 10 productive developers, not good, but productive developers. And 6 months later, he was basically doing all the testing. They gave up on any testing. That's why they had so many problems. Instead of hiring another tester, what we did is we kind of tried to understand, well, the reason why you wanted to hire Samir is because developers did not have the knowledge of how to test. So instead of him being somebody who spends all the time on a keyboard kind of executing these stupid tests all the time, why not get him to teach developers how to test? That's kind of the reason why you hired him in the first place. So that's kind of after that, all of a sudden, not just they didn't have, 30, 40 bucks going to 20, 30 bucks going to production. It's kind of the quality improved significantly, the speed improved significantly, and they decided they don't actually need to hire another tester. Samir teaching them how to test was more than enough. So that's kind of the basic idea of moving to a quality assistance model, where the job of the tester or the job of people who are responsible for quality is not really to execute the tests. It's to help the organization speed things up and help everybody test better. As an idea, it's not a particularly new idea, but I think it's becoming more and more popular because our relationship as an industry to how we approach testing and how we approach quality is changing rapidly. And I think last few years, this is becoming a really, really important practice for teams to adopt because it helps speed up delivery significantly. So somewhere in the 1980s, if I kind of can take you a bit in the history, software was typically reserved for really, really big companies. You had to have really expensive equipment and you had to have people in lab coats operating computers. And at that point, software development organizations could do pretty much anything they wanted. I found a piece of information researching this that in 1980s, project management software cost $500,000 a single copy. Now, if you're selling one copy of your software for $500,000, you can do whatever you want. It doesn't matter. You can have 50,000 testers testing this stuff using chemicals and running around like crazy. You can have developers working in lab coats. You can, do a 5-year delivery phase. It doesn't matter if you make so much money from a single copy of your product. But at the same time, there were very, very few companies actually using this kind of stuff. So the market was very small. Most people were using typing machines, not computers. Now, somewhere kind of in early 90s, we started getting software for everybody. Small companies started buying computers that cost $2,000, and then you don't want to pay $500,000 for software. And our software started becoming a lot cheaper, but lots more people started using it, and many, many more different types of software started getting built. Companies started depending on this stuff a lot more. And the way kind of this started going on, all of a sudden we no longer had people in lab coats. We had floppy disks that, we could start installing. And this is where, because software started being so popular then, we started getting more formal processes. At this point, you had rational unified process. We had proper software engineering, and proper software engineering was done by, proper processes, and there was a way how to do testing. There was a way how to do everything was really specified. There's a lot of documentation, and this is where a lot of the kind of testing now started emerging. And companies at this point started hiring lots and lots and lots and lots of testers because we had to do everything kind of correctly. And at this point, I found some data from Microsoft where in the 90s they had one tester for one developer. That was the ratio. And lots and lots of organizations are now depending on this business software, so it needs to be correct, it needs to be fine, but we're still doing delivery phases that are 2 years or 3 years long. And we have enough time for 5,000 testers to test the work of 5,000 developers. And then Windows 95 comes out, and then Windows 97 comes out, and then Windows 98. So kind of we're slowly starting to speed up the delivery. We're getting from 3 years into 1 year. And at this point, somebody kind of wakes up in all these companies and says, well, we can't really pay 1,000 testers for 1,000 developers. That doesn't make sense. And because we're now getting into a more globalized situation and we can put software on CDs and just, mail it somewhere, then testing starts moving away from where developers are sitting. And companies still want to keep one tester per one developer, but they don't want to pay them So kind of they send it somewhere where this is a lot cheaper. And now, kind of at this time, the relationship of our industry towards testing starts changing from a perspective it needs to be good to it needs to be cheap, which starts becoming a really, really big problem. And it becomes a big problem because the incentives start being completely different. And now we're starting to get a big divide between us and them, developers and testers and things like that. And this is getting to the point where, although lots of people reduced the price of testing, they didn't really improve the quality of their software. And we are still getting faster and faster delivery phases. Early 2000s are where the internet is exploding and we're getting, people starting to deploy web apps once a week, or, some crazy companies even once a day. And when you have a process that requires 500 people somewhere halfway around the world to look at the stuff, and there's a big disconnect between developers and testers, that goes a bit crazy. I, at this point, was working with a large company where they were trying to figure out their strategy for outsourcing testing. And immediately after that, they wanted to have a strategy for outsourcing developers. And I remember us kind of sitting and trying to explain how this is really ridiculous. And the company director insisted that, we come up with a strategy. So we came up with this idea that we should outsource development and testing to two countries that really hate each other. And he thought we were serious because he thought, oh, that's a really good idea. Then, they're going to kind of try breaking it. Now, at this point, the critical problem with lots of software starts becoming slow releases because the internet is exploding. And people are realizing that testing isn't too expensive because of salaries, it's too expensive because of the time it takes to do. So it's not kind of just expensive in terms of let's send it somewhere cheaper, it's too slow. So at this point in mid-2000s, we have this whole explosion of test automation frameworks. We have unit test frameworks, acceptance test frameworks, Selenium starts kind of popping up on the stage, and lots of kind of people try to delete the problem of testing by giving it to a machine. Now, of course, that doesn't really work 100% because you need a human brain to perform a lot of the testing tasks, and you need human expertise. And although automation can help significantly speed things up, we need still somebody to figure out unexpected tests. You can't automate that, exploring, and this is where there's now a big separation between the camps in the context-driven testing community. There's kind of, what is testing, what is not testing, is this exploratory, and all sorts of techniques start emerging there to contrast this kind of high automation level. And kind of now, towards the end of the kind of last decade, we realized that although there's all this stuff that's automated, it's still too slow because there's still a lot of stuff where you need a human to think about this. And you need a human to design the test cases. You need, even if you're going to automate it, you need a human to execute exploratory tests. You need all sorts of other things. And this is where people really start getting on the idea we need to share the responsibility of testing. Very similar to kind of the situation with Samir. If there is a single person or two people working in a group of 20 different developers, there's no way for the pipeline to move at the speed of 20 developers. The pipeline moves at the speed of 2 testers. And this is where lots and lots of organizations start experimenting with models of sharing the responsibility for testing. And one of the really important things that I think we started kind of noticing as an industry at this point is that testing is an activity, not a job role. And there are people who are going to be a lot better in testing than other people, very similar to how there are people who are going to be a lot better in JavaScript development than other people on the team. But as long as the right testing gets done, it doesn't really matter who does the testing. So it's a question of, how do we make sure that the right testing gets done and that it gets done quickly? So this is where we start kind of seeing organizations like King is a Swedish video games company developer. Their most famous product is Candy Crush, I think. And they have this whole approach that they started pushing in order to do faster releases, and they started talking about how the role of the people that are called testers in their team is not actually to go and execute tests for their products. It's to motivate everybody, to teach everybody, to give everybody this kind of higher mission of ensuring higher quality. And now, because our industry loves to play with terminology, we start getting a completely different terminology emerging there. And in order to contrast to the traditional quality assurance model, where we have the tester being responsible for ensuring quality, people wanted to kind of start coming up with a new name for the role. And this is where quality assistant starts popping up as a name for this role, as a way to rename quality assurance. But quality assistance itself is not a kind of particularly new concept. We had now people from companies like Spotify advertising for quality assistance roles, or Atlassian writing how they do quality assistance, and this is mostly a marketing thing. It's mostly a marketing thing because they're trying to promote themselves as being modern and hip and hire good testers. But as an idea, moving the responsibility away from a tester to make sure that there is kind of high quality to the whole team, that's a relatively old idea. I found a reference from 1983. Sam Kainer, who is a legend in the testing community, wrote about how when he became the kind of a director of engineering at WordStar, that was a very old competitor to not a competitor to Microsoft Word. Microsoft Word came later, I think. He had this problem where the testers were responsible for ensuring quality, and that was insane because a tester doesn't build software. He cannot ensure that kind of the right software is built. And in his organization, testers were often the people who are there to bring the bad news. And it was a very, very bad situation to be in, because if you're always just bringing bad news, everybody hates you. And the testers were positioning themselves, oh, we're going to break stuff. And kind of testers don't break things. Those things are already broken before they come to testing. And there's this whole kind of terminological problem there. And what Sam suggests is, instead of kind of calling these group and the responsibility here quality assurance, because it can't really do that, we should really kind of position it more as helping the organization get to good quality, rather than bringing bad news. That's a much, much more important, much better position to be in. So this is where we start kind of seeing this. The first reference to the term quality assistance I've ever seen is from Sam Kainer's kind of post there. I'll share the slides. I don't know whether you can see the link or not, but it's an absolutely brilliant article that he wrote about this, and I think everybody should read it. It's kind of ongoing revolution of software testing. He wrote this article in 2004, so it has a lot kind of more modern than just looking at quality assistance. So kind of this is where we start getting to kind of some interesting statistics. At Atlassian is one of the most famous companies to move to this model completely. They wrote that now they have groups of 5 or 6 engineers, 5 or 6 testers supporting a whole kind of group of 100 developers, product owners, and everybody else. There's some statistics from Google I've read in a book called How Google Tests Software, where they talk about how teams that have a lot of testers at Google have 1 tester for every 25 developers. And we're moving away from this significantly from the old 90s model where 1 tester to 1 developer, because nobody wants this army of testers back. We've realized that slows development down too much. And the way to actually speed up development is to rename this role and to get, not just to rename it, to give it a completely different responsibility. But then we have this big problem of everybody talking about how this is not their job, because we've been programmed for years and years and years to think about a completely different set of responsibilities. When the average developer kind of who's not used to this model hears that they have to do most of the testing, it's kind of, no, that's not my job. And when you tell an average tester who's not been used to kind of something like this to, now you're not allowed to test anymore. Like, well, what do I do now? Well, you know, where? And there's a whole history of separation that's, for some reason, completely, you know, insane, but here, where testers expect to be responsible for assuring quality, and lots of large organizations in particular have this problem where testers don't trust developers to execute the tests. It's like, these people are not stupid. I mean, why not? And you know, we have this whole problem of independence of testing, and we have whether developers are going to cheat if they execute tests to make them pass, and all sorts of silly conversations that here start happening because people start talking about, well, you know, that's not my job. So one of the first things that I think we need to talk about, and somewhere where I can help you maybe if you want to help your organizations transition to this model, is how to deal with this problem. Because actually the practices that I'll talk about later are a lot easier than this. That's ironic. Kind of, so this is mostly kind of an organizational problem. So I worked with an insurance company in England where when they started moving to Agile, as you know, insurance companies do, they kind of declare this big thing, now we're going to be Agile from tomorrow, and their head of testing quit. Because the head of testing attended a conference on testing some months before that where somebody was talking about how there is no role for testers in Agile. So he decided it's best to quit early and find a good job before he gets fired. So we're talking about 2005, 2006 here. So it's not, you know, people were still trying to figure out how to do proper testing in Agile. And very quickly after he quit, he found jobs in the new company for all the really smart testers in the old company. So about 2 months after they started moving to Agile, they lost all their smart testers. And then they started having lots of really interesting problems because they lost all the knowledge about how they want to test and things like that. But they also had an interesting opportunity because they needed to rebuild the testing function from start. So they needed to hire completely new people, and they were trying to figure out, well, what kind of people do we want to hire? We don't want to hire people who will quit at the first idea of we need to work closer with developers. We need to hire somebody completely different. And we were trying to create a job description there, and we ended up using the job description from a finance book called Liar's Poker. In Liar's Poker, when they talk about hiring bond traders, the HR person comes to the traders and said, you know, give me a profile for a successful bond trader. And one of the guys says he needs to be lucky. The luckier, the better. Hire somebody lucky. So we basically came up with that description. Hire somebody lucky, somebody, you know, who can win the lottery, because that's what we need when we're testing. And joking aside, we decided that before actually starting with hiring the testing function, we need the whole company to figure out what service do they want the testing to provide. So we need to turn it around. What is the job of testing, actually? What do we want them to do? And it took about a month of really important negotiations between everybody there. But at the end, they ended up with a definition that I think is absolutely fabulous. They ended up with a definition that the kind of the role of the testing in their organization is not to execute the tests, is not even to kind of define the tests. It's not to do anything that has to do with tests. The whole purpose of testing there was to kind of help the team move faster with more confidence. And I think that's a brilliant definition. I've been using the definition from, from then for everybody, because I think if we do testing properly, we get more confidence to move faster. That's the whole purpose of it. That's why we're doing testing. It's not to, find the bad news. It's because kind of we want confidence that we can release this and we can achieve something successful with this. So with that in mind, they started hiring people, and they found some really, really smart people to start looking at lots of different types of measurements, metrics, lots of different ways of testing, but very, from the first day of new people joining the team, their job was never, ever, ever to be people who bring the bad news. Their job was to ensure that everybody else can get confidence about what they're doing. So this is where I think when we get into really changing the organizational mindset, what I love to do is I love to use a technique from a book called Switch. Switch is one of the smartest books you can read about organizational change. It's a book about how to promote change in an organization where you do not have any political or economic influence. So where you're somewhere in the middle, how do we get people to change their minds and things like that? And they talk about lots of really interesting patterns there. I don't have time to go into the whole thing, but about half of the book is about motivating people that this is a good thing at all, so that we don't get into this not my job kind of. And they talk about 3 steps to motivate people successfully. The first step is to kind of find the feeling of why this change is important. They have this model where they talk about how it doesn't care how much data you present to people. That's never going to convince them. You have to kind of get them to feel that this is a better idea. And then kind of shrink the change and then help them grow. So in terms of finding the feeling, one of the best quotes kind of I found about that, and it's a book called The Heart of Change, is that kind of people really don't change because they get data. They change because they find an inconvenient truth. And an inconvenient truth hurts them. And when that starts hurting them, when they see this thing, then they start changing. So one part of the solution to this that they propose in the book called Switch is to actually visualize the problem. Instead of selling the solution, sell the problem first. And the reason why people say it's not my job is because they disagree that this is even a problem. And there's lots of really interesting ways of selling a problem here. And it's mostly about visualization. One of the weirdest ideas I've heard was actually from Google, James Whittaker, who was he wasn't the head of testing. He had a kind of important role in the testing community there. I forgot exactly which one, but was trying to kind of get developers to deal with issues in the bug tracking system faster. Lots of developers were kind of delaying working on issues. He wanted to get them to start changing, and he actually kind of, instead of pushing people to close up issues, visualized the problem. The way they visualized the problem is they built this small dashboard that had avatars for developers, that had pictures of developers, and had bugs kind of running around the screen. And if bugs were assigned to you in the issue tracking system, bugs start kind of buzzing around your head. So you could visually see if you now have 20 bugs buzzing around your head, and this started annoying people, so they started closing these issues. But then developers, being developers, they got a bit crazy, so they asked for the source code for the website, and then they started adding things like when you close a bug, you can define whether you have a lightsaber and kill it, or whether you shoot it, or things like that. So they kind of started getting a bit crazy. But I think that's a nice, interesting way of how they started visualizing the problem. Another way of how I've seen people visualize the problem, a colleague of mine took over testing at a company where they were doing financial software, and on his first day there, he found that in Jira they had something like 300 priority 1 issues that were, just sitting there. And he was trying to get people to, well, we need to deal with these things. Everything is priority 1. So if you have 300 priority 1 things, well, there's no real priority 1. And what he did is he bought some red paper and he printed 300 tickets physically and plastered it all over the walls. And then when people started coming in, there's like 300 tickets on the walls and they're all red. It's like, well, what is this? This is our kind of outstanding number of priority 1 bugs. And he said, well, this is depressing, take it down. And he said, well, it's depressing for me to look at it in Jira. So, you know, these digital tools, they're very, very easy to hide things because it's a you're invisible list. But if you visualize the problem, people start acting on this. And I think that's part of what makes this thing an interesting kind of proposition. And there's a couple of other weird ways of seeing people visualize the problem. There's a Norwegian company that's an online marketplace where they tried to kind of put a face on quality. And what they've done is they've built a sentiment analysis from Twitter about their users praising them or complaining about them or complaining about mistakes. And they built this really lovely dashboard that was displayed in all the developer rooms where you can see in real time, do people like our software or not? And that was motivating people, motivating developers to improve things even without kind of, you know, going through customer support testers and things like that. So find a way to visualize and sell the problem rather than trying to sell the solution. That's the first step. Now, you don't have to go crazy. You don't have to come up and invent all these kind of weird ways of doing dashboards. Here's some more traditional things you can start showing. One thing I like to kind of visualize is end-to-end delivery speed. So how long does it take for a piece of software to go from idea until it appears in production? And the first time when people actually see this, if you're not measuring it, often it's very, very inconvenient. I worked with one company in Germany where they were talking about how they're doing a 2-week Scrum, but everything was slow. And Germans being Germans, they really like to have numbers on everything and everything indexed and in a database. So they actually had a really good requirements management database, and we just did a small SQL query to do the average time for an item to go through the whole thing. And it was about 15 months. And when they looked at that, it was like, this can't be true. Well, you know, that's your database. So either your database is lying, and then they realized kind of this whole 2-week iteration that they had was just pretend. It wasn't really real. And this really motivated them to start changing the process. So another thing to maybe start visualizing is how long do tasks spend just waiting in the pipeline? When there's a big division between development and testing, and different people are doing test automation, different people are doing exploratory testing, different people are developing, lots of times tasks just sit and wait. So you might have a task that took, you know, half an hour of active work, but it took more than a week to get out. And people often find this as, hey, this looks silly. So it motivates them to change. Another thing to start visualizing, especially from a kind of quality assistance model, is the amount of rework. When a small group of people is tasked with doing all the testing, usually they cannot test everything because there's just not enough time, which means that things tend to come back for rework, and a percentage of rework might be an interesting thing to visualize. One of the best case studies of applying Agile in a large company that I read about is large-scale Agile at Hewlett-Packard from their firmware department. So this is software that goes into kind of the actual hardware, and they tried changing the process several times, but ended up kind of succeeding only when they visualized the problem for everybody. And the way they visualized the problem was, how much work are we spending on maintaining and fixing up previous features, and how much work are we spending doing new things? And when they actually measured that, it was something like 5 to 7% of their time they actually spent doing new things. All the other time is spent on maintenance and kind of fixes and things like that, which was horrible. But then people realized this is horrible, we need to change. And another kind of thing to try to measure is some kind of satisfaction index, especially if you have frequent releases. You can maybe do sentiment analysis from Twitter or kind of polling your users, interviewing kind of stakeholders to show the actual kind of user satisfaction. That might be a really interesting thing to show as well. So those are some more traditional ideas to maybe start and look showing. Kind of the next thing that I think is really, really important from a change perspective is what Peter Senge said. People really do not object to any kind of change. What they object to is somebody else telling them that, you know, what they're doing now is not good and that they need to be better and coming up with a solution. Because, you know, even when people understand the problem, they will disagree about what the right solution is. So the best thing I know how to kind of resolve this is get the whole team involved in designing the solution. After we visualize the problem, get people to actually start suggesting what they feel is the right answer to do. And then we can kind of involve people in designing the change and becoming part of the change itself. It's their idea. That's what makes it really, really compelling. So some things I've seen here is when we visualized, for example, the waiting time on tasks for automation. We said, well, let's get everybody to propose give me some ideas how we can improve this. And then one of the developers on the team said, well, I don't know, like if that automation isn't, you know, brain surgery, maybe we can start taking over some part of that automation. If you tell us what to automate, we can help you automate things. And things started moving slowly, and there was no, you know, not my job, not your job problem there. Now, kind of, the third thing they talk about in Switch, which I think is really, really, really important, is that we need to shrink the change. We need to get a small change that people will accept. And they talk about how people will very, very rarely accept commitment to something they don't know. That's why coming and proposing, let's just get developers testing and testers not testing anymore, that's a big jump. That's a different kind of thing that people will not commit to, or difficult thing that people will not commit to. But what they talk about in Switch is how people are very often more open to accepting reversible experiments. Instead of saying something like, well, you know, from now on, testers don't test, developers test, get the team to vote on ideas and then approach them as a reversible experiment. Say, hey, can we try this as an experiment for 2 weeks? And then if it works, we keep it in the process. If not, we will find a different solution. And using a process like that often disarms a lot of these objections and a lot of these problems to kind of not my role, not my job. Now, kind of the big question then becomes, what do the testers actually do now if we kind of need to define their role? And I think from what kind of the two steps that they talk about in Switch is shrink the change and grow your people. That's kind of, after you visualize the problem, those are the two really important things. And I think kind of rephrasing this for a software process, I think shrinking the change is making testing easier. It's not necessarily executing the tests or defining the tests, but making it easier to do the tests, removing the friction of testing. And in terms of grow your people, I think kind of the answer to that is fairly easy. It's kind of teach other people how to test. So we're going to take a 15-minute coffee break now. And then after that, I will show you some really, really good techniques for kind of teaching other people how to test. Okay, let's take a break. Thank you. Show you some techniques that I've used or I've seen other companies use that I think are interesting as experiments to start teaching other people how to test and how to make testing easier. So more kind of practical than motivational level. And kind of, I think it's worth thinking about techniques on 4 different levels, depending on where you want to start a change. I think there are techniques that are useful for individual development tasks where you can influence smaller scale work, but then you can kind of go all the way up to influencing the whole organization. And different things apply. I think starting small is always better, especially with kind of smaller experiments, but over time you can start approaching things on a higher scale. So from a delivery task or a user story level, on a kind of conceptual level, I think the most important quality analysis role is to teach people to ask better questions. If we want to get people to get their own feedback, if we want to get people to understand better what they're doing, helping them ask better questions about the feature or about the product or about kind of how this is supposed to behave is really, really important. And for that, it's really useful to somehow start teaching people different types of testing heuristics. There's lots of ways of doing that, and I'll show you some of that, but teaching developers what are the kind of usual ways of finding problems is really, really useful here. Another really useful thing is to start looking at different types of taxonomies of tests, because developers often focus too much on looking for expected outcomes, kind of tests that the context-driven testing community calls checking. So verifying that providing these inputs, the system produces these outputs. That's kind of proving that the system can possibly work in an ideal scenario. That's not really proving that there's nothing unexpected there, that kind of there's lots of other things that we want to look at. So expanding people's viewpoint at what are the available types of testing often helps as well. And kind of the next thing that I think is really, really useful to start teaching people to do is how to do boundary analysis. There's lots of interesting psychological books that talk about how at the edge cases, at the boundaries is where people's understanding breaks down. And from a perspective of asking better questions, teaching developers how to find boundaries, how to understand what are the important boundaries, allows them to ask better questions, because then we can talk about, well, what should the system do in this case? So kind of lastly, I think separately from teaching people how to ask better questions, helping people review the risk and understand the types of risk that some piece of work is introducing is also really, really good from a kind of conceptual perspective. Now, at the more practical level, here are some techniques you can try for these things. So the first technique is to help kind of change the role of the testers to focus on the highest risk items. This is what we did with Samir, and I strongly suggest approaching this as a reversible experiment. Saying something like, hey, how about for the next 2 weeks, the testers are only responsible for executing the highest risk tests. You can ask for help if you want to kind of, as a developer, execute one of these things if you don't know how to do them, but it's your responsibility to execute anything that's not the highest risk. That's a really good experiment to try, because then people realize that, okay, I can actually do this. Or they start trying to figure out, well, what do we need to test here? What kind of test do we need to achieve? The second experiment to try is that the testers provide pre-development testing notes instead of actually executing the tests or even defining the tests. This is where a tester can sit down, review the task that needs to be done, and describe the things they would usually kind of test or what types of bugs they would be looking for. And then developers need to come up with the tests to look for these bugs. A third kind of similar approach to that is a QA kickoff that's usually slightly deeper than the pre-development testing notes. Instead of testers just describing the types of bugs they want to do in isolation, this is where the developers, the testers, and the product people brainstorm together testing notes and write down what they would test in a lot more detail than just what types of bugs they would be looking for. Another technique that was popular at Atlassian when they started moving to this model was to assign a developer on test role, which means that this week you are not a developer, you're a tester. Next week, somebody else on the team is going to be a tester, and they have this rotating role where one of the developers is always kind of playing the role of the tester. This is a really good starting technique, but longer term, it's not something that people should keep, because that still creates a way of kind of sharing the responsibility, but it doesn't matter if it's one tester testing or one developer testing. It's a single person doing it. So it's a teaching thing more than a kind of speeding up thing. Another kind of really interesting thing when we talk about repositioning roles is a question checklist. This is a technique that Markus Hammerberg advises people do, and this is by redefining the roles of developers and testers, the developers get a list of questions they are allowed to ask a tester. They can't ask any other questions. And Markus has this example where they had a team of 1 tester supporting 15 developers. So obviously the tester couldn't do all the work, and they created a checklist of what kind of questions developers are allowed to ask the tester, what service they can do. So, and these were the 3 questions they defined, kind of, a developer can ask a tester what a tester would normally test around a particular feature, so then the developer will test all that stuff before giving it to a tester. Another thing a developer can say, kind of, okay, I've already checked these 3 things, is there anything else you want me to check before I kind of give this to you? And the third thing is, well, I don't really know how to test this, can you help me? But that's pretty much kind of the service that the testers were providing in that group. So you can find Markus's blog on markusoft.net. He writes a lot about these things, and his writing is really smart. So the last technique that I think is really, really good on the level of individual delivery tasks are feedback exercises. Feedback exercises come from a book called Sources of Power. That's one of those psychology books I mentioned where they make a case for people's understanding breaking down around boundaries and edge cases. And what they propose as a solution is a group exercise where people come up with nasty boundary conditions, edge cases, problem cases together, but then everybody individually has to write down what they think the system should do in those cases. And then you compare all the answers. If everybody has the same answer, we have shared understanding. If people have different answers, that means we do not have shared understanding. So we need to kind of discuss this. We need to figure out how to, improve it. And this is a good way both for improving requirements and for improving test cases. But in effect, it's a really, really good way to teach people how to ask better questions. So, there's one more technique that I forgot to talk about. Lastly, after a feature has been kind of finished off, a QA demo is something where kind of as you're developing in progress, kind of after you finish that before anybody else looks at it, just a developer demonstrating the feature to a tester, explaining what it does, and then an informal discussion, kind of what types of risks, what types of testing ideas they still have, is a potentially good thing. And lastly, at the point where we start doing automation for the test cases, I think starting to adopt testing tools that can work across different functions. Testing tools that both developers and testers can use is a pretty good idea. Some of the tools in this space are Fitness, Cucumber, Concordion, and things like that. Usually, they have a human-readable way of describing the test case, but the automation goes into a general-purpose programming language, like Java or C# or something like that. And that helps promote collaboration because you can get developers and testers together defining the test, but then developers going and automating it. There's a separation between the description of the test and the automation of the test there. And these tools tend to promote really good collaboration. So at a feature level, at a higher level than just a single development item, one of the kind of things on a conceptual level that a quality assistance role is responsible to do, I think, is help people get into situations where they can be surprised. After all the test cases passed for this development item, in order to know if this feature was done or not, well, getting to, oh, this is interesting, or this is weird, that's kind of what we want to speed up and help people get into those situations. So rather than kind of just teaching people how to come up with boundaries or test cases, I think teaching people how to do exploratory testing is really important, because that's where we can get them into these situations that they are surprised. Exploratory testing is all about looking for unexpected things. On a development task level that I spoke about previously, it's more important to kind of define expected outputs, and on a feature level, then we can look for unexpected things as well, and kind of teaching people how to discover additional information that's not really related to the purpose of the test, but something else that's happening in the background is really, really important. One example that I recently had with the team is we insisted that all the developers, when they're executing any tests, have the console of the Chrome browser window open. Just as a very, very small changes. When you're doing tests, make sure that your console is open. And a couple of developers started noticing that they had 20 more times network requests than what they expected to have. Because the login function was trying to send some analytics information to a module, and the module in the backend was broken. So it was rejecting the message, and it was retrying to send the message all the time. It had nothing to do with that particular test. But they discovered a really, really big problem in an analytics module that somebody else had developed and not tested properly. So kind of getting people into these situations where they discover additional information while they're testing is really important. So here are some practical techniques you can try to do for that. The first one is pair up with developers when you're doing exploratory testing. Get a tester and a developer to do exploratory testing together, and then switch between, oh, I'm at the keyboard now, and then 5 minutes later you are at the keyboard. And then developers learn more about heuristics for exploratory testing. Testers can learn more about kind of what developers have already automated and what they assume. This is a really, really good way of bridging the gap between developers and testers. Another kind of interesting technique that works on a kind of even higher level is called blitz testing or bug bashing. And this is where we take something like, okay, 2 hours or 15 minutes or in some cases a whole afternoon, where the whole team is supposed to just pound the product and try to break it from lots of different perspectives. Usually there is a particular mission where we say, okay, we want to kind of explore payments, or we want to explore authentication, and then product people will look at it from one perspective, testers from another, developers from another, but then kind of organizing cycles of feedback, who's been testing what and what they've broken, and publishing that becomes really an interesting way of kind of teaching people how to get into these unexpected situations. Another potentially good technique on this level is called risk storming. It's there's a couple of techniques with this name. If you Google for risk storming, you will actually find a card game designed to help teams figure out what types of risks we need to explore with a particular feature. And then kind of all of these techniques start with the idea of, imagine this thing being broken, what kind of risks does that open up? And how would we mitigate those risks? And then you open up testing, you open up design, you open up monitoring, and lots of other ideas open up around that. And if you are building a consumer product, if you're building a product that kind of companies similar to you are going to use, a really, really good idea to kind of get people into these situations is what's called dog fooding, or eat your own dog food. And this is kind of getting the company to use the new feature before the customers. This is really popular, for example, at Atlassian, because Atlassian is a software company and their products are used by software companies. So kind of exposing early features to actual people at the companies is a good idea. And another technique I really like to use at a kind of feature level, at a higher level, is specification by example. Specification by example is a collaborative analysis approach. It's a way of defining requirements for a product by getting developers, testers, and product people to together analyze it. And by example, as the name says, revolves around capturing key examples of what the system is supposed to do, key examples of how a behavior is supposed to play out. And these examples are usually very, very concrete. That's kind of the key thing. It's a concrete example of something saying like, when I have a person with 2 passports trying to cross a border and they use this passport to come in, but they use this passport to come out, what happens then? Or kind of some very, very concrete examples. And usually this works by in 3 different phases. In the first phase, we come up with some initial basic examples people propose from different roles. Then in the second phase, we try to identify a common structure for these examples. What are the parameters? What are the variables in all these scenarios? And then in the third phase, we apply boundary analysis techniques to say something like, oh, okay, this is a number. Let's do testing heuristics to come up with more ideas and more examples. And this fits in very nicely with what I mentioned earlier, the technique of feedback exercises. Once you know the boundaries, then you can see if people have shared understanding, and we can look at different ways of mitigating the risk. Specification by example also works really, really well with all those collaborative automation tools. Once we have an example or a set of examples that developers, testers, and product people agreed on, that kind of defines an acceptance test already. And then if we can capture that in a human readable way so people can understand, developers can automate it really, really easily. And this is where we start getting into acceptance testing by evidence rather than acceptance testing by confidence. Lots of teams do acceptance testing by confidence where their business people get a day or a week to play with the system. Instead of that, we start moving to a model where the business people need to propose examples, need to propose scenarios that they would test. Developers and testers extend them, they get automated, and then you present the results in a human readable form. That's why these automation tools become important. So, at the product level, even higher than a single feature, one of the most important things one of the most important roles that a quality assistance function can provide is to reduce the friction of testing, reduce the pain of testing. Testing will never, ever, ever be as important as development. From a very simple reason that you can do development without testing, but you can't do testing before there's something developed. And that's why people will always try to find ways to, reduce the cost of testing, skip testing, avoid testing. And we need to reduce the friction, we need to reduce the pain of testing in order to avoid that. Another really important aspect of the quality assistance role at the product level is to build up dashboards, make things visible, show the current status of the testing progress, show the current status of risk, show the current status of the product, give people a way to make better decisions. The next thing that is really important related to that is to improve the observability of the system itself. So lots of times when we have this distinction between who tests, who develops, the system itself is not really that observable from the inside. And then all these test cases are big, end-to-end, bulky, slow, they break a lot. And working on improving system observability is a really important aspect of improving this. And related to that, working with everybody to introduce different control points where we can actually exercise different types of test examples is important. So from a product perspective, I think it's not just improving the test case, maybe even not improving the test cases, but improving the process of getting to the test cases and a way of executing test cases that's important from an assistance perspective. So one good technique for this is bug reviews. This is where as bugs come in or as critical bugs come in, rather than just solving them, do a proper root cause analysis on important bugs and figure out why they happened and learn how we could have prevented these things coming next time. And related to that, not just necessarily bug reviews, you can look at this for lots of different types of feedback. I work with a company that's developing a collaboration tool now, and we are treating every single customer email as a problem. Like, why did people have to contact us about this? And then this doesn't necessarily get resolved immediately, but it helps us improve the product, improve features, get people to do more on their own. Another technique that's really, really good for this at the product level is called the Attribute Component Capability Matrix. It's a technique developed at Google for visualizing the risk of the current risk a product carries. And it's a way for them to agree when can we release software to production. What kind of risks do we accept in production? What kind of risks do we need to test for before it goes live? so that they can kind of have much better decisions around their releasing policies and things like that. This is a spreadsheet where you map out system attributes that are important from a marketing perspective, like security, accuracy, speed, performance, across system components, and tie them in with capabilities that the system provides for the users. You get a picture like this. This is from Android. They use this to kind of define testing for Android and Google Maps and a lot of other things. So they have then some kind of attributes like simple, elegant, secure, and things like that. They have components. And then each of these kind of things in the middle is actually a bunch of capabilities, risk assigned to capabilities, and how much they've tested. So as they finish testing for the capabilities, these holes fill up. And this is a live dashboard of the risk that the current product status carries. And then they can have policies like when there's nothing risk level 8 or above, we can release. And they can have policies around who's responsible for what type of testing. So very closely related to that is the idea of testing tours. This is also developed at Google. Originally, it's described in a book called How Google Tests Software. And testing tours are paths through the attribute component capability matrix that are predefined. So that's kind of almost predefined test plans. For example, they have a landmark testing tour. A landmark testing tour means go and visit the most important tourist places or the most used features. Or they have a tour called Scottish Bike Ride because apparently nobody in Scotland rides bikes. This is go and look at the capabilities that people don't use that often. So then they can create policies like before every release we have to do a landmark tour. Every 6 months we will do a Scottish Bike Ride tour. And things like that. So you can create these policies around what kind of testing do you want to perform and when. And this is really, really kind of useful. Another kind of technique I've seen work really well on this level is a waste snake. A waste snake is a way to kind of capture what people feel they should not be doing. And you create a limit of, say, 15 minutes. And then if anybody does something for more than 15 minutes that they feel is not really productive or not their job, they write it on a Post-it. And then you put those Post-its on a wall, and because it's limited space, it starts looking like a snake. And then every month you just add up the hours and find where are people wasting the most time. And this is really, really useful from a testing perspective. If you look at, oh, we waited this time for test results, or the test environment was broken, you discover these patterns at a higher level and you can solve them. And kind of lastly, I think on a product level, the best thing, one of the best things a quality assistance function can do is to start building small contextual tools. We have lots of really good generic tools, but for your particular product or your particular environment, you might, help people reduce the friction of testing by building small additional tools. Very often these tools are around setting up the tests or cleaning up after the tests or extracting data, because kind of that might take a lot of time and that introduces the friction of testing. So here's a couple of examples. This is a tool called Bug Magnet I've developed working with a client. It's a Chrome extension where on any input field, when you right-click, you get some useful reminders of names, lorems, URLs, all sorts of stuff you might want to test. And we use this to help developers remember the types of tests they might want to execute. So it becomes really, really easy to do all sorts of left-to-right testing, right-to-left testing, Cyrillic lorems, Latin lorems. They're all available for you. So it's just one small way of reducing that friction. Yes, you can publish this information on a blog or in a database, but have it right-click. Why not? Another tool kind of around extracting information that we build that's kind of contextual like this is a kind of image comparison tool. We have, with a different product, lots of these test cases that are supposed to evaluate layout and how something looks. So instead of humans going and comparing all these things, we just allow the machine to help humans focus by spotting the differences. So we have a lot of these cases, and it's going to capture the expected result and the actual result and just highlight the differences. So that people can very easily see, hey, we changed something here. What changed in my website? I don't want to look through 500 pages. I just want to see the changes. And then I can say, well, yes, kind of, this is the change I expected. That's okay. or I can start panicking. So it's kind of all of these small things that might be important for your context that are not really generic. That's where I think we can start building up these tools. And then kind of higher level at an organizational perspective, kind of speeding up the spread of ideas becomes really important. As different teams start experimenting with different things, one team builds some small contextual tool, another team builds another contextual tool that might be similar. Kind of spreading these ideas becomes part of the quality assistance role. And organizing kind of cross-team sharing, organizing kind of sharing of ideas, sharing of tools, sharing of test cases and things like that. Lots of organizations start developing almost like an internal consulting group there. That you can kind of start bringing in to help a particular team with speeding up the process. And the most important kind of aspect here is don't fix people's tests as an internal consulting role. Fix their process of getting to the test cases. Google had this experiment called Test Mercenaries from 2007 until 2009, and you can kind of Google for that. You can find it in How Google Tests Software. You can find it on Mike Blunt's website. At the end, they concluded kind of it was kind of not really working as they expected. Test Mercenaries were really, really experienced testers who a team could kind of loan for a few months to kind of help them with the testing. And it just doesn't scale, and they realize that after the Test Mercenaries leave, the team just goes back to the old way of doing things. So they kind of fix it temporarily, but there's no long-term solution. So instead of that, getting people to fix the process is a lot more important as an internal consulting thing. So here's a couple of ideas. One is to rotate testers across the teams. That helps spreading the ideas, but also reduces the dependency of a team on a particular person. If you know that a tester is going to leave in 2 months and work with a different team, you can't rely on that particular person too much. The developers have to take a lot more responsibility. And what they were doing is the testers were publishing small articles about different testing techniques, and they were kind of gluing them to the toilet walls, so that people sitting on the toilet would read about testing or something like that. So you don't actually have to do it on the toilet, but publishing these small articles and putting them in places where people can read about them is an interesting idea. Another interesting idea is called Fix-It Days. That comes from Atlassian. And what they do is they organize a whole day where a bunch of volunteers come together and they fix kind of issues that are not really urgent, but they're still important. So things that improve the product over time, but it's also a great way, because they're volunteers from different teams, a great way for them to share information and to learn about these kind of problems. A couple of kind of my very, very large client organizations have used these testing fairs. Testing fairs are almost like a career hiring day where you have different companies presenting and trying to convince students to join the team. This is more internal, where different parts of the organization present what they're doing interesting. And it's almost like a fair, and people go around and observe and investigate what other teams are doing. That's a kind of nice large-scale technique. And the final thing I will suggest at this level is to investigate Mike Blunt's model called the Rainbow of Death. Why he's called it the Rainbow of Death, I don't know. His blog post talks about how that's just a funny name. But so Mike used to work as part of the Test Mercenaries group at Google and wrote lots and lots of stuff about this. So on his blog, mike-blunt.com, you can find all sorts of information about this topic. He ended up working with the American government 18F group, that's kind of the agile development group at the American government. And he defined this model where there's a kind of several-step process. The first step is intervene, where experts actually work with developers to define tests, to kind of test together, to intervene in the way how we are running the test cases. Then the second step is validate. That's kind of help people validate that their work is good. It's their responsibility to do the work, but you help them review test cases. Don't execute them. Don't help them visualize the risk, help them understand the results. Then kind of the next step is inform. It's kind of more let's spread this knowledge. Let's not even involve ourselves in validating that the work is good, but to inform them how to do these things. And then kind of inspire other teams to approach the same model, and then mentor people throughout the organization. So the reason why it's called the rainbow of death is that what they do in order to kind of start designing these practices is they map it out on a multicolor rainbow, and then kind of they plan out different techniques on different levels so that teams at different levels of maturity in a larger organization can choose what to do. So if you go to Mike Blunt's website, you will find this model both for Google and for 18F and for some other places. And these are kind of, they map out all the things that a quality assistance role can provide. And then depending on a particular level of maturity of a team or particular needs of a team, you can choose where they are on the scale and then get involved with them in a different way or a different model. So that's kind of pretty much it for this talk. Thank you very much. I hope this inspires you to start changing the process at least a bit. I have written up on some of these techniques also in my latest book, Humans versus Computers. So if you want more information, kind of have a look at that. Thank you very much. Спасибо.
So basically, the key to success is to involve the team.
Absolutely. Yeah, it's, if you don't involve the team, then it's us versus them again. So it's, if we're talking about assistance, it's assistance to somebody. If you don't have anybody to assist, then it doesn't matter.
Yeah, thank you very much. And the second question is, where do you draw inspiration from, personally? Because I really admire your energy, the drive, and like how to be inspirational for the team, how to be this person who drives.
Vodka.